Hey guys, in my last intro, I showed you what a container was. Well, this is also a container, and I'm covering up the logo here because I don't want to, inadvertently advertise for somebody that's not, asking us to advertise for them. But this is a container also, and today we're going to do containers part 2. Whoops. Hey, Razi, how's it going, man?
It's going great. Thanks for having me.
Yeah, man. I'm just going to call this the Razi Hour.
That sounds good.
That first episode we did with you on blockchain just kind of went through the roof, and this is part 2 of our containers series, and the first episode actually hasn't been released at this yet while we're recording this. But I'm sure it's going to kick butt, and I know it was a lot of fun recording that one with you, so I can't wait to see what we're going to do today.
Oh yeah, I'm super excited. So I actually have a lot of demos. This is going to be more hands-on as usual, but I do have a slide deck just to make sure that we structure it a little bit. And
okay.
We can also do a little bit of a high-level recap what we did in the first part. And what we're going to do in this part and how it's going to go. So let me go ahead and share my desktop here.
Okay. I'm just going to turn it over to you and let you go because you're awesome at this.
Okay, cool. Thanks. All right. So basically, if you look at it, we talked about Windows Container last time. We had a couple of demos. We looked into how you can run and containerize application in using different frameworks like ASP.NET Core, ASP.NET 4.5, and things like that. So that's pretty much like a build part. So today, what we're going to do, we're going to talk about the how we take that and take it to the next level. Basically, we need to make sure that we deploy it in a consistent fashion. How we do CI and CD, which is the continuous integration and deployment. We'll talk about all the major components over there because there's a lot going on. So we dig into that. And we're also going to basically do a run and monitoring piece, which is like when you deploy it using Azure Container Service, we will see that what are the different ways and different options it provides you and how we can just streamline everything end to end and have monitoring and diagnostics going on. So before we go into a little more technical details, let's talk a little bit about the DevOps in general. And this is important because technology is a critical piece, but there are other aspects in DevOps that are also critically important if you wanted to make it successful. So a good example would be like if I ask you to build this massive Lego structure. This is the European telescope, a large telescope. And how would you build it? So in order for you to build it, you basically need a couple of things. You need to start with the building blocks. So you have to have all the pieces with you, all the blocks. You most likely wanted to work with other people because if you wanted to work it alone, it will be massively difficult task. You can, but it will take way too much time. So usually the way it works is that to make it successful, you wanted to have all the blocks fit together and make it happen. And hopefully we'll get the Lego piece together.
Yeah, you need super glue too.
Oh yeah, you need super glue too. Yes.
Yeah, because so that if somebody knocks it off the table, it doesn't.
Oh well, break. Yeah. I mean that is pure evil. Do that. So basically, the idea here is that the technology is really the tooling part of it, and that's really critical, But culture and the process are equally important. So culture is something that basically empower people in the team to feel that they're part of the team and they will work together. And that is something that takes time. And based on my experience working with different customers, large teams may be highly agile. Sometimes small teams are highly agile, but it really depends on how the leadership is driving that culture. The other thing is the process, and traditionally there are strong focus like let's have a very like a concrete process in place, which is good to a certain extent, but the idea of the process is to basically remove the roadblockers. That's what it is. So process for the sake of process most likely is not a great thing to do. Less is more when it comes to the process. You just want to have efficiency of a process. You don't need just like a bunch of processes out there that you have to manage. And culture always going to supersede process because that's how people are. When it comes to the tooling, tooling is something that you think about it as right tool for the right job. And don't necessarily like take one particular tool and then use it as a Swiss Army knife. And this is where I guess the Azure is a great example. Like we support both our own products and services, and we also support open source. So depending on the customer maturity level and the need, we can help them out in any way. We don't necessarily have to choose like one product and stick with it. So at the end of the day, DevOps is like this triangle, like culture, process, and the tools working together to make it happen. You have to invest in all three pretty much. There is actually a story on Visual Studio website, there's a link right there, that talks about Microsoft journey into the DevOps, which is a great example, like how we land into DevOps and what are the lessons learned over there. So that's something that is definitely interesting for the audience. So I put it there. Okay, anyways, so let's start with our bigger picture. What we essentially wanted to do is we wanted to build a continuous integration and deployment pipeline, and we will use ACS. ACS stands for Azure Container Service, and we will use a Visual Studio Team system. That's what we're going to do. So what we're going to build today. So we will actually build a very simple microservice. And actually, if you remember from the first part, we have this ASP.NET Core web app and the web API. I will talk about that momentarily, so I'm not going to go in detail right now. But we will build that and we'll deploy it as a microservice using VSTS and into the ACS. So we will actually go ahead and put it into the VSTS, and we will use Docker Azure Container Registry, which supports the Docker Registry protocol. We store our images over there because we need a place, and we need a place where we have full control over it, like who sees it, who can access it. So it's important that you don't necessarily want to use everything public. You want to have something private. So we will use the Azure Container Registry, and then we will use the Azure Container Service to run this. So where you run this is basically you will have, in this particular demo, we will have DCOS and Swarm. So DCOS and Swarm are two very common orchestration engines out there. Kubernetes is the third one. I will talk about that, but I don't have it running, so I didn't put it here. But Kubernetes is another one that we support on ACS. And we'll take our service and we will actually deploy it simultaneously into two different clusters. Now, this is a great example. We are using ACS to expedite the process of deployment and creating and managing these applications, because otherwise, if you do it on your own, creating these clusters itself takes time. So Azure ACS basically provide you a mechanism to host these multiple clustering platforms and then use them as much as you need them. So that's basically where we deploy it, and then we wanted to monitor it. So I will be using Operations Management Suite for that. You can use other third party, I will mention them. But there are ways that you can actually go ahead and perform some analytics. You can set up alerts and things like that based on the criteria that you wanted to put in. So the user is actually going to go and connect to it using a regular, let's say, browser, and they will technically hit the load balancer that is set up through the ACS service, and they will land on a web page. So basically, this is like a high-level picture, like what we're going to be building, and we will go through like each particular component in detail, and I'll show you like how it works. Sounds good?
Yeah, that sounds great.
All right. So with that, let's talk a little bit about the building blocks. So the application we are building is a multi-container application. It's like your very simple, basic. So the idea here is not to build something complicated, but just to have something that we can relate to. So I'm using ASP.NET Core. You can use Node.js. You can use literally any application platform framework for that matter. We will build the Docker images, and the way we're going to build it is that the build definition will automatically going to create the images for us. And that is important. Whenever you check in the code, we wanted to make sure that there's an automatic process that actually build these images and tag them properly. So we will use VSTS build definition for that. And it will actually build those images and push them into the Azure private Docker registry, which is the Azure registry. So that's basically the storage piece. Then we will actually have to go through the actual build and release. So build process will build it. Release is basically like which of the target environments you wanted to deploy this multi-container application. So we'll be using DCOS and Swarm as an example in this demo. So ACS is the orchestration engine, and finally we have the operations management suite, which basically perform the analytics. So a little recap about the application. The application is basically a web app, which is a front end. It's ASP.NET Core 1.1, runs in a container. In the first part, we build it on a Windows platform. I will actually basically just take the same code and put it on a Linux container. And the reason why I have to put it there, because at the time of this recording, both DCOS and Docker Swarm, they support Linux container on ACS. They don't support running Windows container yet, but that will change soon. But the semantics are same. So basically the same code base we are running in a Linux container. So the web app is actually a front end, and the web API is basically it returns a JSON, famous quotes from famous people. So they all dress up nicely, by the way, if you notice.
Well, so I see Mark Twain, I see Teddy Roosevelt, and then I see Woody Allen, and I'm not sure how Woody Allen fits in with, well, I guess maybe with Mark Twain, but not really with Teddy Roosevelt. But anyway, go ahead.
Yeah, I actually just basically searched on the web and found out a nice JSON file. So that's the reason behind it. It's not me thinking too much about, maybe I should have put Francis Ford Coppola there, maybe. So
no, it's fine. It's fine. I'm just making fun of it. Just, it's no big deal.
Okay. All right. So with that, let's do this. Let's take a look at the demo for the multi-container application, and I will introduce a concept which is called the Docker Compose. It's a tool that allows you to basically describe your services, multi-container applications as a services. So if you recall from the last time, right, we have this sort of like a discussion like, hey, if you have a web app running in a container and a web API, how they will discover each other and things like that. And you will see that how the Docker Compose will help you in doing that. So with that, let me switch over to something that I really like, which is a console, and I just need to find the right one. Here we go. So to set some context, I am inside a terminal, and I'm on my own machine, by the way. I'm just using a terminal to work through the command line here. And if I do the listing here, you will notice that I have a web API and a web app, 2 folders here. So let's quickly take a look what's inside these. Okay, here we go. So this is the web app, and we have a ASP.NET 1.1 web application, and we also have a Docker file, which is basically describing to Docker that, hey, this is what we wanted to build. And if you notice that, basically, we're just pointing at the DLL here, which contains the actual code, and then we also copy the published folder, which have all the dependencies in it. So it's really pretty much as simple as it can get. So let's get out here and take a look at the web API. So let's go into the web API, and the web API is pretty similar, and I will just show you real quick. Here we go. So the web API is basically, so we have to actually provide this instruction here, because the default AT is exposed, but if you wanted to expose other port, you have to specifically tell it. But other than that, is the same. It's pretty much the same story. So pretty basic. Now, one more thing I would probably quickly show you guys is if we go back real quick to the web app, and we go into the controller here. So let me see the name of the folder here. And so if I scroll down a little bit, and we can actually open like some text editor if you prefer that, but I just thought to just take liberty and show you right and everything, you know.
Yeah.
No,
No, that's fine.
Okay.
That's good. Yeah.
Okay. So notice what we are doing here. What we are doing is that we are accessing the API, and we are basically using the demo web API like as an FDQN pretty much. And the idea here is that once we deploy these services, the web app and the web API within the container, we will have Docker resolve this name for us. So basically, Docker internally will find out whenever there's a request coming in for the demo web API from a container, web app container, it will go ahead and direct that call to a container running the web API. And the benefit is that once we take this and we deploy it in a cluster environment where you wanted to scale things, you don't necessarily want to work with IP addresses or the actual host names. You want to work with something that can be resolved, and then you can scale based on that. So if you wanted to run like 500 copies of this container, you will let Docker run the 500 copies and make sure the call goes to one of the containers. And also the benefit of using this rather than hostname particularly is that containers get killed and then you basically spin up new containers all the time. So having an association with a host name or IP address is not necessarily a great thing, although you can do that if you want to. So that's pretty much it for the application part. Now what we will do is, if we go back a little bit, and let me clear this. So there's another file called the Docker Compose, and if we do Docker Compose, so what this file does, it basically have this structure. This is the YAML file, so it is not specifically a format that is created by Docker, but they leverage that, and it's actually pretty easier to understand and deal with. So it basically have everything as a services, basically like microservices. So it says, okay, we have services here. What type of services we have? We have the demo web app and we have the demo web API. Now the demo web app is, we are saying that, well, there is an image called the demo web app. So basically use that image. If you wanted to build the image, you can use a build option here and it will build the image for us. But right now I'm using the image because ultimately when we put it into the VSTS, we want VSTS build definition to build it for us. And after that, we're saying that, okay, what port we wanted to map. In this case, I'm mapping port 8000. And the only reason I'm using port 8000 because I will be using another demo here, DCOS demo, which will basically occupy port 80. So I don't want to touch that. But you can use port 80. You can pretty much use any port that is available. And we map that. So that's pretty straightforward here. But look at this one, depends on. The depends on actually tell the Docker to basically understand that this web app has a dependency on the demo web API. So it will actually do a couple of things. It will first of all make this particular demo web API discoverable from the demo web app using this particular name. And that's the reason why we can use that HTTP whack web API.
Yeah.
And it will also make sure that it will spin up this particular web API container first before the web app, because web app depends on it. So it intelligently try to deduct that. Okay, let me spin up this one first. So it will do those two things.
So it looks like these are all essentially properties that we have to define so that we can access demo web app.
So one way to look into this is when you have more than one application that have dependency on another one, then you can use this YAML file to basically describe the dependencies and the structure.
Okay.
Yeah, so basically, typically you will have more than two, right? So if you have, let's say, 6 services and you have to structure them and have a dependency defined, You don't have to use YAML, like this particular Docker Compose tool and YAML file, but this just makes your life easier. That's the reason. It's more of a convenience factor.
Okay. Cool.
So with that, let's get out of this file here. And what I will do now, so basically as a developer, I wanted to test it out locally first. So what I will do is I will do Docker Compose. That's the tool. And you will notice that it provides very convenient semantics that you will expect, right? So you'll say Docker Compose up. Up means like, hey, bring up my services. And I want them to be in the, I can choose like interactive mode or the detach mode. And the difference is that if interactive, once the execution is finished, basically the application, the container will cease to exist. So I will go ahead and do Docker Compose up /d because I want to run detach, and then we'll bring it down later on. So it will go ahead and it will create those services. And if I do Docker PS, which is listing for all the running images, you will see that we have the demo web app and we have the demo web API. And the demo web app is running on 8000 and the web API running on 9000. So the easiest way to test it out is, well, you can use curl, but HTML output not going to be that, typically not going to look aesthetically pleasing. So I will go and open up a browser here and go to localhost 8000, and this will bring our web application. Here we go. And for us to test the codes, I can go ahead and click here. And here you go. So we have these codes here from the JSON file. Now I can also test my web API. So I can say localhost 9000 API and codes, and it will give me basically displaying the JSON file. So typically at this point you have automated testing and you have other form of tests that you have to run. So you can do that too. But let's do this. So basically we have this running. If you wanted to stop this, the way you do it is you do Docker Compose and you do down. So basically the Docker Compose up, bring up the services, the down will bring them down. So you will notice that it will stop and it will remove.
Yeah,
so yeah, so you see it's more convenient and of course more structured. So it's pretty handy. So at this point, let's say I'm ready to check in this code and I'm using VSTS for that. So let's go ahead and look into like how the VSTS piece is. So before we do that, let's go and talk a little bit about what we're going to be doing there and about Docker Compose, the recap. So here we go. So Docker Compose, as we saw, is basically a tool defining and running multi-container applications, provide services capability, command line tooling, and things like that. So basically, pretty handy. So before we go to the registry, let me do this. Let me go to the VSTS. So I have this Visual Studio Team system. This is the service. And I have actually pushed the code that you saw right here. I mean, you can use the GitHub desktop or use simple command line. Doesn't really matter. I will skip that part because it doesn't necessarily add real value. But you just basically have to push the code for some means right here. So once you have your code over here, what you do is let's say in this particular case, what we really want to do is that every time there is a code check-in, I wanted to basically start a build. And probably you wanted to run a build as a part of code check-in process, a continuous integration process, and then based on the outcome, you wanted to basically have a container created for this particular application, these two applications, and then push it somewhere. And that somewhere is basically going to be a registry. So let's talk a little bit about the registry, how it works. So we have in Azure, you can actually create, we provide it as a service, which is the Azure registry. So you'll notice that the Azure registry, I have created it. And if I go and click on the repositories here, you will notice that I already have the demo web app and the web API and few other applications that I was working on. I pushed them here as a container image, and you'll notice that there are tags, and these tags are basically defined whenever I'm doing the build. So how this all work, right? So first of all, if you want to create this, you can create it either using the portal. So you go here and you do Azure Docker registry, and this is the option right here. So you basically go ahead and create that, and this is basically not like a proprietary Microsoft way of dealing with the registries. It actually based on the open source Docker registry v2. So it's something that that is pretty much like an open source. We just basically provide a hosting mechanisms here. The benefit of hosting is there are a couple of benefits. Actually, let's go and talk a little bit about it. So the benefit of having a Azure Container Registry is that you have your own particular private repository. The alternative is that you can actually use the Docker public hub, which, if you recall from our previous session, is something that is pretty much free. This is like my particular repository, and this is the hub.docker.com. It's actually good to play around with Docker and images, but if you really wanted to look into the production level environment, and most of the customers may not want to have everything on the public, so they wanted to create or have a private repo for that. So basically what we are having here is that there's something private to you. You can manage who can access it, who can perform like an operations to it. It's fully compatible with Docker Registry v2, so you can use the Docker CLI command line to access it. In fact, later on when we create a build definition, you will notice that it's exactly going to use the Docker CLI to connect to the container registry. So we have the container registry for us, and if you go back and look into the registry we have over here, so I'll just go back. And the Docker registry, here we go. And you can actually look into some of the details here as soon as it open up. Let's take a look at, so basically this is the registry name, this is the login server, this is the username, and this is the password that that I will be using. I will actually change that after this demo. So yeah, yeah. I mean that's
I don't think you need to worry too much about it unless somebody's doing a screenshot.
Well, yeah. I mean,
yeah.
When it comes to security, you have to be paranoid, you know.
Oh, of course. Of course.
So, all right. So that's the registry piece. So if you go back over here, so we have our code here, and we have a piece of the infrastructure that we need. So if I go in and look at the build and releases section right here, and go into the builds first. So I have a build called the multi-container app build. This is the name of my build, and if I go and edit it, you will notice I have steps here, and if you look at the logo, these are basically Docker related tasks. So if I go and click on this one, I will show you how I added them. So within these task catalog, Microsoft have these extensions that you can download, which is basically for the Docker related interaction with the Docker. So what I'm doing right now is I added one of these tasks, which is basically here connecting to my registry, and I will show you how I'm doing that. You can actually go into the services, you can create a service endpoint, and this endpoint is actually connecting to our registry. So the registry that I just showed you a moment back. So basically we are connecting to it, and that will use it during the build. So if I go back here, so this is my registry. I am actually telling it that how I'm going to basically go and build an image. Now, every time, whenever there is a code check-in, we wanted to go build a new image. Because remember that, let's say for the web app, I wanted to make a change in the background color. We wanted to take that change and create a new container for it. And we will package that container from one environment, like we will package it as part of the build and we will push it into the registry, and the same container will be deployed into all the environments. In this case, we have like a basic test environment, but you can create like test, pre-prod, UAT, n number of environments, and then final prod. So think about it like the unit of deployment is not the code, is the container. And there's significant difference between how traditionally the applications have been deployed. And the benefit is that because the container is same, it provides you with a higher level of assurance that the application will perform in the same way. So the first thing we'll do is that we actually build, and what we're building is the web API. And how we're building it is simple. Basically, we have the Docker file that I showed you earlier on. We have it also in the, of course, as a code. Here's the file. So I'm saying that, okay, go ahead and use the Docker file to build an image. Now, one thing that we'll do here that is different is that we will push this particular Docker image, and we push it into the private repo, and we also tag it with a build ID. So the reason why we want to do that, we wanted to make sure that every time there is a new build, we can identify which build it is. Now I'm using a very basic sort of like a convention here. I'm using the build ID. If you wanted to use something more complicated and advanced, you can do that. But the idea here is that you wanted to somehow differentiate between the builds. Because if you don't provide this tag, everything will end up with a default tag, which is latest, which may not be convenient when you look at multiple clusters and find out like why things are not working. So troubleshooting will be much easier if you can identify which particular build it is. And that's actually pretty much it. It's as simple as that. So we do a basic build here for the image, then we push it into the registry. So this will build it, and this will actually push an image into the particular registry. Now, one thing that we need to talk about a little bit, and I do have a PowerPoint slide for that, but let's just continue with the momentum here. Basically, you wanted to have an agent where this build will run. So you need a machine. So you can define that machine like a VM. So I have a VM that actually running a VSTS agent. We'll talk about that momentarily. And that is where this build is happening, because we need to run it somewhere. Now, VSTS have this option where you have the hosted agents, which is basically hosted online, or you can create your own like a VM and then install an agent, and it will connect to your particular build. So I'm doing that. So we basically do this build and we push it to the Docker repo. Then we have the build again for the web app. And finally, we push this web app into the repo. So basically, we have two images coming out of this build. And then we do a little bit work on the Docker Compose file. Because if you remember the Docker Compose file that we used, we didn't put any tags in it because on my machine, everything is latest, right? I don't care about the versioning. But in this particular scenario, I do care about the versions because I want to deploy the latest version. So the way I'm doing it is one way of doing it is if you look into the code here, and if you look into the Docker Compose, you will notice that I have this build number tag here. And what that task is doing is that it's basically replacing that with whatever build number for this particular build. So that's one way of doing that. And finally, we're taking that Docker Compose file and creating pushing it as an artifact. So later on, when we release it into a cluster, like we deploy this, we need a Docker Compose to basically create the services and run them the same way I did it on my laptop, but we want to do that in the cluster itself. So this is the build piece. All right, so one more thing that we can do is if we go into this trigger section right here, you will notice that I have this continuous integration option. So when you turn this on, basically the build will commence every time you do a check-in. And when you do the check-in, it will go ahead and start the build. The containers will be, created and pushed into the repo. Now you can choose to do it selectively. You can basically say, I do not want continuous integration. Someone will do it on demand, and that's fine too. But for this one, we just use it for the demo. So we basically have the continuous integration option selected here. So this is the build, and let's take a look a little bit into the release, and we will come back to this after we dive a little bit into the Azure Container Service, so we understand a little bit on the side like how things work. But just to show you like how generally things are here. So what I have over here is we will deal with two different clusters. We will have a DCOS cluster, and we will have Docker Swarm cluster. So think about like two different environments where I want to deploy my microservice. So one is DCOS, the other is Swarm, exactly the same containers, the same build that basically generated them, and then finally getting deployed into these two clusters. So I have two different definitions. And the way it works is that whenever you have a build, and whenever that build succeeds, it will automatically kick in this release. So if I go and edit this, you will notice that we have one environment here because I have only one cluster. So this is let's say our test environment, and we wanted to have our multi-container application deployed here, and I have one task here which is deployed to ACS DCOS. And again, this one is provided by Microsoft, so we basically just using that. It's not like I created it. And the only thing you really have to do is first you have to connect to the Docker registry. This is the same registry we've been using. So we will want to make sure that we have the latest container from there. It will give you an option like which is the target type. Right now is DCOS because we wanted to deploy there. It will ask you about the Docker Compose file. And Docker Compose file, if you recall, the build generated a Docker Compose for this particular, for a specific build. So we have it as part of the artifacts. And here it is. And after that, the task will take care of doing the actual deployment. So there's the DCOS. The Docker Swarm is another platform that we're using. So for this one, it's similar. It's a little bit more involved though, because there's a different platform, so it has a different needs. But essentially, we're doing the same thing. We are connecting to the, we're basically going to connect and download the, connect to the registry, download the particular images, and we will stop the containers and we will run the commands to actually do the deployment. And we'll see that momentarily. But the idea here is that you can come in and you can define another one for Kubernetes, for example, or maybe some other platform that is not existent yet. But you can actually go ahead and define as many release definitions as you can. All right, so let's do this. Let's go back a little bit and talk about some of the other items, and we'll come back and actually run this build and then see how the release goes. So we talked about VSTS quite a bit, and I was actually looking into VSTS history. I started working on VSTS many years back, and I was looking for this like publications, and Brian Harry, of course, he's very prominent in the field. He wrote about it many years back, like 2004 actually, a little history on me and the Visual Studio Team system. And then last year when they're going into the VSTS, he has another post called Team Services TFS Roadmap. So it's an interesting contrast right there, 2016 and 2004. And we used to have these, remember these?
Yeah.
I think this is a DVD, by the way. So this is a progress writer, it's not a CD. I actually wrote an article back in 2007. And that's me, by the way. I had long hair. So.
That's got to be a DVD, because if it was a CD, there'd be a lot more of them.
Yes, exactly. So from left to right, history to the modern, and now we basically is predominantly cloud, or you can run it on premises too, TFS. Yep. So Visual Studio Team system, just a quick recap here. It's it's a multifaceted service in the platform. So it has release management, CI/CD, agile tooling. I mean, it's a holistic. I mean, we can have series of sessions on that. Fantastic tool and service to work with. One thing that I will show you real quick is the agents. Agents is basically when you wanted to build your code. In this case, we are basically building a container image. We need at least a place where that can happen. So you can have the private agent and you can have the hosted agent. Hosted agent, as I was talking about it earlier, Microsoft provides the agent and takes care of maintenance and upgrades. The private agent is basically you have to bring like a VM and manage it. And the reason why I'm using right now for this one, because there is sort of like a need right now to have a private agent at the time of this recording. This may not be true in the future. But I also like that I have full control over the agent itself. If you want to download the agent that I'm using, you can just go ahead and use those links. I will show you right now the VM and where is that? Let's just go and make sure. Here it is. So let me just clear it. And you will notice that I have this folder called My Agent. If I go into the My Agent, this is the tar file. So I'm basically using Linux as a tar file, and I'm running basically as a service. You can run it as a interactive, or you can run it as a service. I'm running it as a service, and I can actually go and list down the service, and you will notice that there is it starts with V. So I need to scroll a little bit. Here we go. Believe me, it will come up. Here we go. So here you go. So VSTS agent, and this is the name of my VSTS service, and it's enabled right now. And whenever we're going to kick a new build, you will notice that the Docker container will actually be created here. And we'll take a look at that momentarily. So I will just go back here. So right now, if I do Docker images, you will notice that it doesn't have one of our API or the web app, but after the successful build, you will see that. So let me just clear that. So that's an important component. We definitely need that. The other thing I wanted to mention, we won't go in detail today, but Visual Studio 2017, which is launched very recently, now they have a much more advanced tooling facility. You can actually do really like a click deployment on using VSTS and ACS as a service. So basically, the option is provided through the continuous delivery tooling, and this is the snapshot right there. Basically, what you do is that you provide it with the registry, you provide it with the service, the ACS service, the subscription detail, and it will actually do the continuous delivery deployment for you. So there's one option on the table. A lot of customers are now moving towards 2017, so I thought to mention that. But if you're on the lower versions of previous versions of Visual Studio, or if you wanted to customize settings and want to take control, then you can of course go back and then do it yourself.
Hey, Razi, that was awesome.
Hey, thanks. Always great to share the knowledge.
Yeah, man. Listen, thanks again, and I can't wait to have you back for part 3. I think we're going to do containers in Azure, correct?
Yeah, we're going to talk about the Azure Container Service as a hosting platform for different orchestration engines, and also a little bit about monitoring and analytics.
That's awesome. Hey, I'll make you a deal. If you wear that shirt, I'll wear this shirt.
Oh, awesome. This is Ethereum, so yeah, you should check it out.
Well, guys, that's it. That's your taste of Premiere.